Now let's apply the Born postulate to these few questions that are coming up. Now let's look at this one. Consider a particle confined to move in a rectangular area shown below. So let's just limit our particle to this area that's marked by this red rectangle. Write down the definite integral that must be equal to 1. What's the integral that must be equal to 1? Integral of psi, absolute value of psi squared d tau must be equal to 1. But this is more specific, so let's be more specific. Exactly what do we mean by d tau here? Well, that means your psi here, if you recall, will have to be a function of x and y, right? So you need to integrate with respect to x, the square of psi, absolute value of psi, from x equals, okay, here's your x-axis, so negative 1, negative 2, 1, 2, 3, 4, 5. So from x equals negative 2 to 5. And after you've done that integration, you integrate the result with respect to y. And integration from y, for y would go from negative 1, negative 2. So from negative 2 to 0, 1, 2 to positive 2. And so we say that that integral must be equal to 1 if we insist that the particle is somewhere in that rectangle. Okay? Now, just a little bit of a math review about doing multiple integrations. Let's say you have something like a function is equal to, let's say, x squared y. Okay, what would be the integral of f dx from, let's say, x equals 0 to 2, and let's say from y equals 1 to 3? Well, what you do is you substitute your f there, right? And so you would have integral from 1 to 3 dy, and what you have here is, okay, what is that? Integral of x squared y dx, okay, from x equals 0 to 2. Okay, what is that? As far as this integration is concerned, you're integrating with respect to x, so you treat y as a constant, so that factors on the y. What's the integral of x squared dx? That's going to be integral of x to the n dx is just x to the n plus 1 over n plus 1, right? Plus an integration constant, which disappears if you do a definite integral. So this is going to be x cubed over 3, evaluated from 0 to 2. And let's put that in here. So that's going to be y times 2 cubed is 8 over 3 minus y times 0 over 3. Okay? So now that becomes integral from 1 to 3 of, what is this expression right here? That's just 8/3 y dy. 8/3 integral of y dy is just y squared over 2. Okay, integral of y dy is y squared over 2, evaluated from 1 to 3. So that gives you 8/3 times 3 squared over 2 minus 1 squared. That's how you multiply equations. Okay. This is the same problem we had earlier. What's the unit for psi squared? Again, you have one particle, we said. It's going to be a function of x and y and t, actually. By the way, that when you said just when we ignored t back here, what we really meant was for a given instant in time, you do this integral, which is just going to be a function of x and y. Okay. So, what would be the unit for psi squared in this case? Well, psi squared, okay, remember you're integrating with respect to x and y, right? So that expression right there, psi squared dx dy, must be unitless. But what's the unit for dx? The SI unit for that is meters. A length of a unit of length. dy is in meters. So psi squared must have units of per square meter. Okay? That would be the unit for psi squared. Let's take a look at this question right here. Let's say this time you have two particles confined to move in a rectangular area shown below. Right? The definite integral must be equal to 1. This time we have two particles. So our psi must be a function of x1, y1, x2, y2 times. It has to depend on the coordinates of both particles. So the integral that we have to write would be integral. Okay, let's start up over here. Integral of psi, absolute value of psi squared dx1 from x1 equals, x goes from -1, -2, 1, 2, 3, 4, 5, 6 to 6. So from -2 to 6. The result of that, you integrate with respect to y, 1, with respect to the y coordinate of particle 1, and you go from, that's -1, this is -2 right here, 1, 2, 3. So from -2 to +3. And after that integration, you get whatever result you get. You integrate with respect to x2. From x2 equals -2 to 6 again. Okay. And then the result after that, you integrate the result with respect to y2. And you integrate from -2 to +2. And this entire expression must be equal to 1 if psi is normal. Okay? The particle is in the system, the two particles are in this box right here, and this entire integral must be equal to 1. Let's consider two particles confined to move in the rectangular area shown below. This is the same problem as this one right here. Right? Two particles. So what would be the unit for psi squared? Let's look at our psi squared. Okay. That entire integral must be unitless, right? So psi squared times dx1 times dy1 times dx2 times dy2. That entire expression must be unitless. So we have to say that psi squared dx1, dx2, dy1, and dy2 must be unitless. So if that's the case, then these are units of length, so that's meters, that's meters, that's meters, that's meters. That's meters to the 4th next time. So that means your psi squared, absolute value of psi squared must be meters to the -4. That would be the unit. Now, how about this one? Let's consider a particle, this one particle, confined to move in the rectangular area with red borders shown below. What would be the definite integral for the probability of finding it just in this blue area shown here? You would expect that to be less than 1, right? Because the probability of finding it within the entire box, the red box, would be 1. But how would you determine the probability of finding it in just that little area there? You would say then, you just take the integral of psi squared, okay, dx from x equals, let's say, it's 1, 2, 3, 4, 5. So from x equals 1 to 5, and then you integrate over the y values, okay, and y, you want to go from y equals 1 to 2. And you would expect that number to be less than 1. Why less than 1? Because that's just a small part of the entire range of possibilities where you can find your particle. How about one particle confined to move in a rectangular area shown here? Okay. Okay, actually this is two particles. So psi here is going to be a function of x1, y1, x2, y2, and time. So for a given instant, what would be the unit, what would be the probability of finding particle 1 in this blue area and then particle number 2 in this green area? So you would say that would be the integral, okay, of psi squared, so the value of psi squared, dx1 from x1 equals 1 to 2, and then you integrate the result with respect to y1, and y1 goes from 1 to 2 also. And then when you get the result, you integrate this time with respect to x2 from -1 to +1, and then integrate with respect to y2 from -1 to +1. So okay, and again, you would expect that number to be less than 1 because that's not, that's not for certain that you're gonna, if you find 1 here, you'll find particle 1 in the blue box and particle number 2 in the green box. That's not for certain. For certain, but they're both in this entire box, somewhere in the entire box.